What if I told you sound is powerful enough to make objects float in midair? No magnets, no strings, just invisible waves defying gravity. Here's the incredible physics behind acoustic levitation. Most people think sound is just something we hear. Music, voices, thunder. But in physics, sound is much more than noise. Sound is actually a mechanical wave. Every sound travels by pushing air molecules together and pulling them apart thousands of times every second. These tiny pressure changes normally feel insignificant. But what happens if you increase the frequency, increase the power, and control every vibration with incredible precision? Suddenly, sound becomes a physical force, a force strong enough to push against gravity. Acoustic levitation begins with two special speakers called ultrasonic transducers. Unlike normal speakers, they don't produce sounds humans can hear. Instead, they vibrate around 40,000 times every second. That's about twice the upper limit of human hearing. When two of these speakers face each other, their sound waves collide. But instead of simply passing through one another, they create something extraordinary: a standing wave. This invisible wave becomes the secret behind levitation. Imagine throwing two identical waves toward each other. Where they meet, they interfere. Some places become extremely high pressure. Others become almost motionless. Scientists call these locations nodes and antinodes. These pressure zones create an invisible three-dimensional architecture floating in the air. Think of it as an invisible staircase built entirely from vibrating air. Tiny objects naturally settle inside these pressure pockets. Once trapped, they simply stop falling. Gravity pulls downward. Sound pushes upward. When the two forces become perfectly balanced, the object floats. This is where things become truly incredible. Normal conversation measures around 60 decibels. A rock concert reaches about 120 decibels. Acoustic levitation systems generate nearly 160 decibels. Fortunately, this sound is ultrasonic, meaning humans can't hear it. At these enormous pressures, air begins acting almost like an invisible solid wall. Instead of flowing around the object, the vibrating air constantly pushes from every direction. If the object drifts slightly, the pressure immediately nudges it back toward the center. The object becomes trapped inside what physicists call a potential well. It's like placing a marble inside a bowl. No matter where it moves, it naturally rolls back toward the middle. Except, this bowl is completely invisible. Floating objects is just the beginning. Using invisible sound waves, scientists can move, rotate, and precisely control tiny particles and even living cells without ever touching them. This incredible technology is called sonic tweezers. Acoustic levitation isn't just a science experiment, it's already changing the future. Scientists use sound waves to mix medicines without contamination, move delicate electronic components without touching them, study living cells more naturally, and observe chemical reactions without containers. It's a groundbreaking technology that's transforming medicine, electronics, and scientific research, all using the invisible power of sound. Scientists believe acoustic levitation could play a major role in the future of space exploration. Instead of robotic arms, spacecraft may use sound waves to move delicate materials without touching them. Researchers also envision contact-free factories, advanced 3D printing, and ultrasonic haptic technology, all powered by the invisible force of sound. The next time you hear the word sound, remember, it's more than something you hear. Under the right conditions, sound becomes a force powerful enough to defy gravity, move matter, and shape the future of medicine, technology, and space exploration. What once seemed like science fiction is becoming reality, and this is only the beginning. Thanks for watching.